Hey everybody, tonight's flip is on the equations of parallel and perpendicular lines. So the first thing you want to notice in parallel lines, and make a note of it, is that in parallel lines the slope is always the same. In the two equations below, without even graphing, you should be able to look at these two lines and say with clarity that these two lines are parallel because you see the slope 2 is the same. The y-intercepts, of course, are different, which means they are not the same line, and they will have no points in common because the two lines have the exact same rise-to-run ratio, and they are passing through the y-axis at two different locations. These two lines will never cross because their slope is the same and their y-intercepts are different. Please make a note of this fact. From now on, when you hear that two lines have the same slope, you should recognize always that they are parallel. Also, when you hear that two lines are parallel, you should recognize that their equations will have the exact same slope. This is true for lines with slope of 0. It's also true for lines which have undefined slope. Say, for example, x equals 2 and x equals 10. Here are a few examples of lines that are parallel. Each one of these lines has a slope of 1/2. It runs 2 for every 1 that it rises. It runs 10 for every 5 that it rises. This is true on all of these graphs. They have the same slope, 1/2, 1/2, 1/2, 1/2. Please pause this video for a second, and based on the graph, write in the y-intercept of these two missing values. Also, see if you can figure out what will the y-intercept be for a line that's parallel but passes through this location, which is -10, -10. Go ahead, pause the video. Okay, welcome back. Well, hopefully in this equation you said this is y equals 1/2 x plus 1. And then for this equation it was y equals 1/2 x, 1, 2, 3, minus 3. In the last equation, there's several ways you could have done it, but a lot of folks would say, I'm going to run 10, therefore I'm going to rise 1, 2, 3, 4, 5, and I am then at -5, so this is y equals 1/2 x minus 5. A second option for working through this, and one that is much more convenient when you have a point that is farther away and off the graph than -10, -10, or when you have a coordinates that's not so nice integer values with a convenient slope, is to solve for b, the y-intercept, algebraically. Here you can see the setup to solve for b algebraically. By completing the algebra, I find that b is equal to -5, and I simply write in -5 for the y-intercept with the same slope, 1/2, because I know these lines are parallel. Here's a similar problem. See if you can do it on your own. You're to find the equation for a line passing through 6, -5 that is parallel to y equals 3x plus 5. You should note it's parallel to y equals 3x plus 5. Go ahead, see if you can get the answer. Pause the recording, I'll walk you through it in just a second. Okay, so hopefully you worked through that okay, and you said to yourself, look, the slope here is 3, so I'm going to reset this up with 3. I need to find what b is, and I have a point, 6, -5, that will help me find b. So 6 is the x-coordinate, goes in here for x. Negative 5 is the y-coordinate, goes in here for y. And after you simplify, 3 times 6, 18. Take away 18 from both sides. You end up with b equal to negative 23. You're not completely done until you get it back in the equation. So the final equation for a line that's parallel to y equals 3x plus 5, passing through 6, negative 5, is y equals 3x minus 23. These lines share the same slope, but they have different y-intercepts. These two lines will never intersect. Perpendicular lines are lines that run at 90 degrees to each other. Perpendicular lines will always intersect at some point. Here's an example of a line that has a slope of 2/3. A perpendicular line will cross this line at some point. Its slope will be different in two ways. First of all, if the first line is positive, the second line will have a slope that is negative. If the first line's slope is 2/3, the perpendicular line will have a slope that is the reciprocal, 3/2, and its opposite. Perpendicular lines have opposite reciprocal slopes. Please make a note of this. It will be on quizzes, it will be on tests. It's gonna be there, folks. Make a note. Perpendicular lines have opposite reciprocal slopes. Knowing that all lines that are perpendicular have opposite reciprocal slopes, please give the slope of a line that will be perpendicular to these 4 examples. Pause the recording, write them down, and then I'll give you the solutions. So for the first one, the slope was 3. Opposite reciprocal. The reciprocal is 1/3. The slope of a perpendicular line will be negative 1/3. For the second one, the slope was negative 2. The reciprocal of negative 2 is 1/2, and opposite of negative 2, positive. Opposite of 1/2 positive is going to be negative 2. The opposite reciprocal of negative 3/5 is positive 5/3. Here's an question that's a lot more specific than the previous 4. Find the equation for a line that is passing through a particular point and perpendicular to y equals 1/2 x plus 2. So in this question, you will use the 2 previous skills. 1, to know that perpendicular lines have opposite reciprocal slopes, and 2, knowing that if you're given a particular point, you can substitute it into an equation to solve for b. So you plug in the opposite reciprocal slope, negative 2. You plug in the point 6 in for x, negative 10 in for y, and you solve for b. Negative 2 times 6 is negative 12. You add 12 to both sides. 2 then is equal to b. What's the equation for the line? This line will have a slope of negative 2 and a y-intercept of 2. Y equals negative 2x plus 2 is the equation for the line that is perpendicular to y equals 1/2 x plus 2 and passing through 6, negative 10. Okay, so for the last part of your homework, here's the challenge. Can you find the equation of a line passing through negative 410 and parallel to this line? And almost the same question but different. Find the equation of a line passing through negative 410 but perpendicular to this line. So you should have 2 separate equations for these 2 questions. Thanks a bunch. I'll see you in class.